Hi, I want to welcome you to my video, which is on Enhanced Interior Gateway Routing Protocol, or EIGRP. My name is Thomas Twig, and this is for advanced routers and routing for Baker College in Flint, Michigan. If you wish to follow along, you can go to this URL, Net Academy / courses, and you can download Packet Tracer, and when we get to the configuration portion of the video, you'll be able to follow right along and configure your network like mine and learn about EIGRP a little bit more. What I want to do is I want to cover some understanding of basics understandings of EIGRP. I want to talk about neighborhood table, or neighbor table, not neighborhood table, but neighbor table, topology table, routing table, and we're going to take a look at those when we get into the configuring. Also talk about the feasible distance, the advertised distance, the successor, and then the feasible successor, and what those are and what do they do. And also two very important items that go along with EIGRP, which is Reliable Transport Protocol, or RTP, and Dual, which is Diffusing Update Algorithm. And then we're going to get into configuring EIGRP. Now, one of the things you need to understand before we go any further is that EIGRP is a Cisco proprietary protocol, meaning it will not work on your Dell routers or any other router. For that case, you may want to use what is known as Open Shortest Path First Protocol, which is OSPF. And there's other videos out there about that. Again, this EIGRP will only work on Cisco routers. And EIGRP, like the earlier Routing Information Protocol, or RIP, it is a hybrid protocol of Advanced Distance Vector Protocol, meaning it is going to find the best possible route to send a packet, whereas RIP is limited by the number of hops, which is, I believe, 15. After 15, when it hits 16, it drops the packet. EIGRP is not, and it is designed specifically for larger networks. EIGRP can handle up to 100 hops. The main purpose of EIGRP is also, it's all about topology, and it's all about changes, and it's all about updates. It's very fast, and it's very reliable. Now, one of the other things it does is it does support IPv4 and IPv6. That's important. There's also support for VLSM and for CIDR, which would be your subnet masking. And then also, it reduces the bandwidth usage with bounded updates. So that's important too, and that's one of the things that makes it quite fast. Now, the other thing I want to talk about is that there is no broadcast. So let's talk about the casts for a second. One is unicast, and unicast is going from one source to one destination, meaning one-on-one. Broadcast is going from one source to all possible destinations. So that's one to all. And then multicast is from one source to multiple destinations and that are interested in receiving the traffic. So not every router on the system may be interested in receiving traffic. Maybe, for example, you have an email that needs to go to certain departments and it doesn't need to go to all departments. So that email, which would be a packet, would only go to certain areas. It wouldn't go to everybody. So it's one to many is the idea behind that. Now, some EIGRP basics. We're going to take a look at the neighborhood tables and the neighbor tables, and the neighbor table maintains the information on the neighbor router's information via hello packets, and we'll get into that a little bit more here. And also, we're going to take a look at the topology table. Now, your topology table also provides information on all the paths to destinations, and also your topology table shows you which one is the successor route, meaning which is the best route to a destination, and it's going to provide all that information. And then you also have your routing table, which is best possible route to destination, A little bit different than the topology table. The topology table is going to show you the successor, whereas the routing table is not going to say, hey, this is the successor, this is the best route. Okay, then we're going to talk about feasible distance, which is the total distance from the router to the destination, and the advertised distance is from the neighbor router to the destination. And then feasible successor is the second best destination for the route. Now we're going to talk about reliable transport protocol, or RTP. RTP, like EIGRP, is a Cisco proprietary protocol, meaning again that it will not work with others. RTP is also sometimes referred to as reliable multicast. RTP handles messages in 5 different ways. One is it provides update packets, and these packets contain information on metrics and also topology changes. Query packets, and some of these seem like they overlap. A query packet is a request for specific routes, okay? And then reply packets are packets that are sent in response to query packets via unicast. So a query packet may go out, it may say to 3, 4, 5 different routers, hey, what is the best path possible? Router number 3 says, I'm the best path possible. And here's the reply back to the original source. And then you have hello packets, which are used in EIGRP neighbors and is sent via unreliable multicast. Now, what this means, unreliable, is not the sense of the path is no good or the path is good, but that it does not require a response, is what it means. And so when a hello packet is sent, the hello packet is going to contain the router's information. Is sent to the neighbors. It also sends the routing information to the neighbors. So that router 1 is going to tell router 2, hey, I'm here, I'm alive, I'm working, and also here's all the different routes I have available. And then an acknowledgement packet is a response to an update and is always used unicast. So hello packets don't require a response, and acknowledgement packets also do not require a response. You don't need to acknowledge my acknowledgement. Diffusing update algorithm. This algorithm is what is responsible for maintaining the best path to each router in each network. Dual is responsible for EIGRP to function quickly. There's 2 important things you need to know about Dual when in relationship to EIGRP. 1, know all their neighbors' routes, and in order to calculate the cost to the remote network, meaning that cost is going to play a part in the successor or the feasible successor. And then also, if query of the topology table does not work, then the EIGRP can solicit the neighbors for help. So if router 1 looks in its topology table and can't find the answer that it's looking for, it can reach out to its neighbors and say, hey, which is the best route possible? Dual is also responsible for figuring out backup routes. If there's one available, it also supports VLSM. And also it sends out queries for alternate routes. So what we're going to do at this point is we're going to head on over to Packet Tracer. We're going to go ahead and configure a router for IP addresses and for EIGRP. The network's already been set up. All the other routers have all been configured. Due to time restraint, we're just going to do one router, and you'll see how it works. It works out pretty good. And so if you have any questions or any comments at the end of the video, please, by all means, leave your questions or comments. I'll do my best to answer. So I'll see you on the other side. Okay, we're back. And I have my network all configured. Because of the restraint of time, I have already configured these 3 routers. I named my routers Texas, Michigan, Indiana, and Florida. So Texas, Michigan, and Indiana have all been configured for IP addresses and also networks and also EIGRP. And so let me show you real quickly what I did here so that you can have an understanding of what's going on. So we started out with this network here. So the whole network is 192.168.10.0 with a CIDR 24, and then basically what I did after that was I determined based on my topology what networks I would need. So if you come over here to network 1, we have 125 hosts. Network 2, we have 64 hosts. Network 3, 22 hosts. Network 4, 10 hosts. Then networks 5, 6, 7, and 8, 2 hosts each. And so then I broke them up. And one of the things I like to do in Packet Tracer is I like to put my IP addresses where they are supposed to be. And so it makes it a lot easier, as you will see, when you get to that point. It makes it a lot easier when you start programming your routers to be able to look and say, okay, this serial port should have this IP address. And so it lays it out and makes it a lot quicker. Let's go ahead and get started. I don't have Florida programmed, as you can see. As you can see here, I have Indiana programmed, and you can see the IP addresses in there. And you can also see, let's see here, I guess it does not show you the EIGRP neighborhood or settings. Okay, so we'll get to that in just a minute. And what we're going to do is we're going to start off here. When you start off with a router, it's going to ask you, would you like to enter the initial configuration? We don't have a configuration done, so we're just going to hand jam it all. All right, and you start off in the prompt here. We need to elevate, so enable. And then if you ever get stuck and you're not sure of a command, just do a question mark after whatever, and it will give you all the commands that are available within that prompt. So what we want to do is we want to do a config T to enter the configuration mode. Now we're in the configuration mode, and now what we're going to do is we are going to program our router with the IP addresses. So let's start off with the network 3, and let's go ahead and program that interface. So all you have to type is int stands for interface, and then the port. So the port that we're concerned with is this one right here, and that's going to be G, and you can put gig, you could put gigabyte Ethernet, whatever. G is fine, and that's port 0-0 or 0/0, and now we're into that port. And we're going to tell that port we're going to give that port an IP address. Notice that I did add and then tab, and it completes the IP address. And then now we want to put in the IP address, which is going to be 193, and that's a CIDR 27, so that's going to be 255.255.255.224, okay? And enter, and we want to keep that router up and running, so we're going to say no shut. All right, now we notice it's up, and you notice here I have a green light, okay? Now, also one of the things that we want to do here is the next port we want to do is port 000. Sometimes you got to move this stuff out of the way. Now, notice here, this is very important to look at. On serial port 000, we have a little clock here, and that's important because we're going to have to configure the clock rate for that link. If you notice over here at Texas, there is no clock link or clock rate, no clock here, so there is no clock rate on that link. And you need a clock rate. So we're going to go ahead and go into, we're already into configuration of the interfaces. And so now we're going to change to interface 0/0/0/0/0, and we're going to give it an IP address of 192.168.10.250, and that is a submask of, getting ahead of myself here, 255.255.255.252. And then because of the clock, we have to set the clock rate, and that clock rate is going to be $64,000, the $64,000 question, and then again, whoops, no shut. All right, and that link is up and running, and now we're going to do interface 0/0/, whoops. All right, now we're going to do interface 0/0/1, and we're just going to repeat the process here of inputting the IP address, which is 192.168.10 right here. Let's put this back where we got it. And for 001, it's that one right there, so it's going to be .254, and that is a CIDR 30, so that's going to be 255.255.255.252. All right, and we don't have to worry about a clock rate there, so no shut. All right, so now our router has the IP address. If you want to pause the video and copy these commands for the whole network and copy the network, feel free to do so. Now we're going to go into EIGRP. And so I got out of the interface command so that we can re-enter config mode because we're in the enable mode. And now we're going to configure for EIGRP. The first thing you do, if this was the first router or the last router of the network, it doesn't matter. So we're going to do router, EIGRP, and every network that uses EIGRP has to have the same anonymous system, or AS. Some people call it the process ID number. That number has to be the same for the whole network. So I've already used all the other ones have already been, all the other routers have been programmed with an AS number of 10. Okay, then once that is completed, then you put in your network. So we'll start again with the gig port 000, and that is a network of 192.168.10. And if you look over here, that's network 3, so that's going to be 192. Whoops, forgot a dot, 10.192. And instead of putting the subnet mask, what you're going to put in here then is the wildcard. So this is a CIDR 27. And the CIDR 27, what you want to do here is to figure out what the wildcard is 24, is you want to subtract 255.255.255.224 from 225. And if you do that, what you're going to do is you're going to end up with a 31. So the way you put the input, the wildcard, is 0.0.0.31. And that is the wildcard. So unlike putting in regular network addresses, you put in the wildcard here. If you don't put in the wildcard, you're going to run into some problems. And now we're going to finish up, and let's do this one here. All right, and input that network. You can actually just tab up, and this is a CIDR 30, and that's going to be a 3. 250, and look at that, that's up and running. And remember, we talked about that dual right here. It's already established. A new neighbor is established. Okay, and the new neighbor is 249. Okay, so next we're going to do the next network, and that is going to be this one right here. And it is a CIDR 30, so we're going to leave the wildcard the way it is. And we're going to change that to 4, hit enter, and there you go, it's up and it's running. So now let's get out of this. So we're up and running now, and now let's look at some of our tables that we talked about. So we're going to show IP route, and there you go. This is the IP route. Notice everything is in here. Everything is routing. I can talk from one network to the other network, and there are no problems. And hopefully we will have no nulls in our tables here. So next we want to do a show IP EIGRP topology. And this, remember, shows our successors. And notice here I have two successors, and this could be a problem later on, but because of time restraints, we're not going to talk about how to handle that. But you don't want two successors. You want a successor and a feasible successor. But since this network is fairly small, there are no feasible successors. So, but here, notice that everything is the same. So you have two successors here, and again, you don't want that. And there's a way to handle that. You can turn off auto summary for one. And next, we want to show IP EIGRP neighbors. And so if we look at this here on the Florida router, you have a neighbor of 249, which is this one right here, and a neighbor of 253, which is this neighbor up here, which is Indiana. So that's how you do EIGRP basics and how you basically configure a router for IP addresses. I want to thank you very much for watching my video, and take care.